first half. The first half of the unit was all about multiplication. We started off with like little things, monomials, and then we slowly grew it all the way up until we were doing area diagrams on really big things like trinomials and trinomials. We then did a little bit of word problems as well, just to kind of mash it all together. Today marks the start of the second half of the unit. All right. So today marks the start of the second half of the unit, which will be unmultiplying. We call it factoring. So when you hear the word factor, essentially what you're going to be doing is unmultiplying polynomials. Now, it is essentially division, but you're going to see it get to the point where it doesn't even look like division anymore. So we call it factoring, unmultiplying. That means you should always be finishing with a multiplication question after you're done factoring. If that makes sense, you're unmultiplying something. So you're taking it and you're turning it into a multiplication question. The first type of factoring that we do is called greatest common factor. You're also going to hear me refer to it as GCF. We did it at the beginning of the year with just numbers, and we did it with those trees. This is a different type of greatest common factor. Okay? So this will include letters and variables. It'll also usually use smaller numbers. So, you know, you guys are doing GCF when looking at multiple numbers that are really big. These GCFs will be pretty small, so it won't be too crazy. Okay. Factoring. Factoring is finding numbers that multiply together to create what you have. So for instance, we've done this before. We've taken numbers like 30 and we have factored them or written them out as multiplication statements. So 30 could be changed to be 2 times 3 times 5. And that's what we did at the start of the semester. We took numbers, we changed them into multiplication statements. We called it prime factorization, remember with the trees? That's what we were doing before. You can also technically do it with letters. So if I took y to the power of 2, I could rewrite that to just be y times y. See how I factored it so it becomes a multiplication statement. Greatest common factor. This is when you're looking for things that could divide into both things you're given. So for instance, this question right here, question A. We have 2x squared and 6x. We're going to try to identify the greatest common factor between those two things. To do that, you start with the number. You're going to look at the 2, you're going to look at the 6, and you're going to ask yourself, what's the biggest number that divides into 2 and into 6? So 2 would be the biggest number that divides into both things. Right? 6 couldn't go into 2, but 2 could go into 6. Then you look at the letters. This one's x squared, and this one's x. And you ask yourself, what's the most number of x's that could divide into both of those? Just one x, right? Just x. It'll always be whatever the lowest exponent is. So in this case, x could divide into both of those. X squared could not divide into both of those. It could go into the first one, but not the second. This thing that we just wrote out, we call that the GCF. That's the biggest thing that could divide into both of the statements I was given. So if we looked at B, or number 2, and I said, what's the GCF of that thing? You look at the number first. What's the biggest number that could divide into -4 and -12? 4, right? 4 could divide into both those. And we would say -4 because they're both negative. So -4 could divide into both of those. Now, you're going to look at the letters. You have x to the power of 3, x to the power of 2. What's the most number of x's that could go into both? X, Sandra? Yeah. X, how many? Square. I thought I heard somebody say that. But both of these could be divided by x to the power of 2, right? The lowest exponent is the one that goes in.
Oh, so I was thinking that it had to like actually go into like that one. I thought that it had to be x4 and x2, and then the 2 can go into the 4.
Oh, that makes sense. I see. Because you had to go into all of them.
Yeah.
Yeah, that makes sense. No, all you're doing when you're doing the variables, you're going to take the lowest exponent. That'll always be what can go into all of them. Like this one, the first one has 3 x's, right? X to the power 3. And this one has 2 x's, x to the power 2. So you can divide by whatever the least amount of x's is. If I tried dividing by 3 x's, there's not enough to divide into the second one. Right? But there's 2 x's that can divide into the second one. Okay. Number 3. Let me try again. You want to do the greatest common factor. So you check your numbers first. What's the biggest number that can divide into 14 and negative 4? Yeah, it's 2. So Allie's got it right. 2 can divide into both of these, and that's the biggest number that could divide into both of those. So 2 starts us off when we're talking about our G's. Now we're going to get into letters. This one's a little different because some of them have X's and some of them have Y's. So you're going to separate the letters into separate pieces. I'm going to look at my X's first. So I have X squared and X to the power of 3. What's the most number of X's that could go into both? That one would be 2. So it would be X squared. Then I look at my Y's. So my Y's are a whole separate part. I have Y to the power of 1 and Y to the power of 2. So the most number of Y's would be what, Aaliyah? 1. You got it right. So 1 Y could go into both of those. That thing right there is called my GCF. All we're doing in this moment is identifying what our GCF is. Number 4. This time, you have 3 things to look at. So when you're comparing numbers and letters, you have to compare all the numbers. So I need to find a number that divides into 12, 18, and 9. Yeah, what is it? 3 can divide into all those. Is 3 the biggest number that can divide into all those? It is, right? So that's the greatest common factor for the coefficient. 3 is the biggest number that goes into all of them. Then I go on to my next letter. It's C. I have C to the power of 5, C to the power of 7, C to the power of 4. The biggest number of C's that can go into all of them is 4. Awesome, because that's the lowest exponent out of all of them. So C to the power of 4. Then you move on to the D's. You have D to the power of 9, D squared, D to the power of 5. What's the most number of D's that could go into any of those? 2. So D squared. That right there is my GCF. I haven't done anything with the GCF. I've just been identifying them. Any questions? Pretty straightforward so far? All right. Now we're actually going to do something with those GCFs. So, when you're factoring, the very first step to every factoring question we do is going to be remove the GCF. I won't usually use the word remove. I'll just say GCF it. Like, take the greatest factor out. Greatest common factor, remove it. All terminology that you'll hear me use. So this question says, factor by removing a greatest common factor. To be able to remove a greatest common factor, a GCF, you have to be able to identify the greatest common factor. So that's the first thing you do. You take a question like this, which is 9x squared minus 15, and you're going to try to identify the greatest common factor. So what's the biggest number that can go into 9 and 15? 3. I would write out a little 3. Then you're going to move on to the next letter. You're going to say, what's the biggest number of x's that can go into x squared and x? A single x. That right there, that's 3x. That's my GCF. So I've identified it. Now I'm going to remove it from the question. Okay? So I'm going to look at each one of these things and divide it by the GCF. So you'll see they've taken each term and they've individually divided it by the GCF. 3x, 3x. And whatever's left over from each of those division things, that's what you're left multiplying your GCF by. So, if I was to take 9x squared and divide it by 3x, 9 divided by 3 would equal 3. That's where that 3 came from. X squared divided by x would give me x. You subtract the exponents. So that's where that 3x comes from. Negative 15x. So negative 15 divided by 3 would leave me with negative 5. X divided by x would leave me with no x's. So that's where that negative 5 came from. And notice that it's in brackets. And what you have is your GCF times whatever's left when you divide your GCF out of your original question. This is called removing a GCF. So if you get told to factor something, the first step will always be to remove a GCF. This is what it looks like once I'm done removing a GCF. The first thing is I identify what the GCF is. The second step is then I divide by that GCF and write out what's left over. And I should be ending with a multiplication question, which I am. Okay, let's do it again. So they've done a little bit for us. It says remove a GCF. The first question is to identify your GCF. So the biggest number that can divide into negative 4 and negative 18 is negative 2. The most number of x's that could go into x and x squared is a single x. And the most number of y's that can go into y squared and y squared is y squared. This is my GCF. That's the first thing I'm writing in my answer. My GCF goes outside. Then you're left with bracket. And the inside of the brackets is what's left over after I divide out my GCF. So now we're actually going to do that division. That's what they've written down for you. So notice that they've taken each term and divided it by the GCF. So if we actually tried it, and I tried to do this division right here, you go numbers with numbers, letters with letters. So negative 4 divided by negative 2 would give me positive 2. If you're not sure, you can always use your calculator for that. X divided by x would give me 0 x's. I don't write anything. Right? They would cancel each other out completely. There'd be no x's left in that first term. Y squared divided by y squared, what would they do? Completely cancel out. Perfect. Right? There's 2 on the top, 2 on the bottom. That means there's none left. You then move on to the second term. This minus sign, we keep it with the 18. So I would go negative 18 divided by negative 2. And that would give me a positive 9, so it becomes a plus 9. If it had given me a negative 9, I would have gone minus 9. Anybody have any questions about that? So negatives we keep with the top number. Alright, we then have x squared divided by x. What do we do to the exponents? We subtract them. X squared minus x to the power 1 would leave me with just 1x. So x to the power 1. I have a y squared divided by a y squared. They would completely cancel each other out, leaving me with no y's. Then I close my brackets. Look how I've removed the GCF out of the question. My GCF is out front. What's left over from division is in the brackets. I've created a multiplication question. I unmultiplied. That's going to be the first step to a lot of questions in the second half of this unit. We're going to build a big tree of factoring. And the first step to that tree is GCF. So it's a very important skill. Alright, I want you to try to factor number 3. So go ahead and give it a shot. At the very least, see if you can figure out what the greatest common factor is. Okay? We will do it together in just a second, but try to figure out what the GCF is, and try actually removing it. Alright, identifying the greatest common factor is what I'm going to do right now. So I look at this thing, I do numbers first, so I have 15 and then negative 35. The biggest number that goes into those is 5. I then look at my letters. I have an x squared and an x. The most number of x's I could take out of both is 1x. And the trick to this one is I look at my next letters, there's no y's and there's a y there. So the most number of y's I could take out of both is 0. So there's no y's in my GCF. 5x is the GCF. So hopefully you got that. Now I want you to try to remove 5x from that question. So see if you can do that next step. Removing that GCF. So now that I have a GCF, I put a bracket. And then I'm going to try to divide each one of my terms by my GCF. So if I look at my first term, which is 15x squared, and I divide it by 5x, 15 divided by 5 would give me 3. So that was the number with the number. And then x squared divided by x would give me 1x. So my first term, when I take out a GCF, should have left me with 3x. My next term, it's negative 35xy. So negative 35 divided by 5 would give me negative 7. X divided by x would leave me with how many x's? 0, so there's no x's in the second term anymore. And y divided by, did I divide by any y's? Nope, so the y1 is still there. That's what the greatest common factor looks like. Alright, we're going to do something. This one. So I look at number 4. For greatest common factor, it has to be something that can go into all of them. So I tried to color coordinate. The greatest common factor is in red. Okay, so the biggest number I could take out of all those is 6. Why couldn't I do 6x? Because there's no x in this third term. Right? And it's got to be something that can divide into all the terms. So that's usually something that people fall for on that one. The next thing people usually fall for is when they're taking out their greatest common factor. And they're dividing all these things by 6. They do the first two properly, and they struggle with this one because they go 6 divided by 6, and the instinct is to say they cancel out, right? And people have been saying that to you for so long, it's just it cancels out. But they don't cancel out. 6 divided by 6 equals 1. So you have to put a plus 1 in there. A little bit of a hint. If you do greatest common factor, if I start with 3 terms, I should always end with 3 terms in my brackets. There's no way or time it should ever change away from that. So whatever I started with, I should finish with my brackets. Another hint, I can check to see if I'm right. The way I can check to see if I'm right is I could then look at my question that I just unmultiplied. And what do you think I could do to see if I did it right? I could multiply it. I could distribute that 6 in and see if I get the same thing I started with. So 6 times 2 would be 12x squared. 6 times negative 3 would be negative 18x. And 6 times 1 would be plus 6. If you did it properly, if you multiplied back in, you should get the same thing you started with. So you can loop yourself all the way around and see if you did it right. If you didn't have that plus 1, you wouldn't have had the plus 6 when you multiplied it back in. And that's another way of knowing that that plus 1 was important. For 5, the same thing happens. So if you go and you take out your GCF, the very first term, when you divide 2x squared z to the power 4 by your greatest common factor, you'll notice they're the exact same thing. But 2 divided by 2 equals 1. That's why there's a 1 to start things off. What if there wasn't 2's? So what if there was no 2 in this at all, and I had x squared z4 divided by x2 z4? We say those cancel out, correct? If they cancel out, what do they actually equal? 1. So even if there was no numbers, and I took x squared divided by x squared, it equals 1. Right? You always have a 1. Alright, word problems. The first one says simplify and factor the following polynomials. So if I went to factor this right now, I could take a 2 out of everything. Correct? But what's the first word it says before factors? Simplify. So if you want to simplify that, that means collect like terms. You have a lot of like terms here. You have 2x and negative 10x gives you negative 8x. You have 6y and 12y is plus 18y. And then you have 8 and negative 16, which is negative 8. You have to do that first before you GCF. When you GCF that now, the biggest number that can go into all those is still 2. But now you have a trinomial instead of a 6-term polynomial, so it's easier to take out your brackets. If I did negative 8x divided by 2, I'm left with negative 4x. If I did positive 18y divided by 2, I would get positive 9y. If I did negative 8 divided by 2, I get negative 4. So I tried to color coordinate again so you can see where each number went. The negative 8x turned into the negative 4x and so on and so forth. Red with red, green with green, blue with blue. Alright, the next one. Factor the polynomial. I want to give you a second to try to figure out what the GCF is of that thing. So that's all you're doing right now. Try to identify the GCF. What can I take out of that question? So that should always be your first step. What is the GCF? I'll give you about 30 seconds kind of to think about it. All right. I start this off by looking at the numbers. So the 4 and the 16 They both divide by 4. Where this gets a little tricky is with these pi's. You can basically treat pi the same way you treat a variable. So if they both have pi, then you can take that out. If only one of them had pi, then you couldn't take it out. Do both of these have pi? We do. So pi would be part of the greatest common factor. What I don't want you to do is multiply both those numbers by pi, because then that creates a crazy number. You just leave them as pi. Then you move on to your letters. They both have an R, so you can take one R out. What about the H? Why can't I take the H out? Yeah, Kate, why can't I? Because there's only one H. This term is missing the H. So if it doesn't have an H, you can't take it out as part of the greatest common factor. It has to be in both terms. So my greatest common factor for this question is 4 pi r. Then I put a bracket, and I got to figure out what's left after I divide out or remove my GCF. So this first one, if I went 4 divided by 4, that would give me 1. If I went pi divided by pi, that would give me 1 as well. And then if I went r squared divided by r, that would give me single r. Do I need to write the 1 in front of it? No. If you did, you're not wrong. Okay, so if you went 4 divided by 4 and put a 1 here, you're not incorrect. It's just not how we normally write things. Okay, if you don't put the 1, it means there's a 1 there. Mathematicians are lazy. They do stuff like that all the time. Okay, so this is just R. Think of that GCF. The second one, in blue, because I like blue better than green. So if you have positive 16 divided by 4, you're left with a positive 4. So you put a plus sign there, and then 4. Pi divided by pi would cancel out. R divided by R, cancel out. H divided by no H's would still be an H. That would be removing a greatest common factor. If you did it properly, you also should have something inside the brackets that have nothing in common. So notice how if I looked inside the brackets, they don't both have R's and they don't both have H's. It's because I've done it properly. If one of them had an R and the other one had an R, that means I didn't take out my greatest common factor properly. It means I missed something, or I did something wrong. All right, our last question, the numeric response one. That is a question that is very similar to things you'll see on a test. That is a perfect numeric response question. It's in fact an old question that we used to have on a test. We took it out and we put it in the notes for practice and stuff. I want you to just take a minute to read it and see if you can figure out what it wants you to do. You don't have to do anything to it yet. Just see if you can figure out what you would do on this question. And we'll talk about it. If I read this question, it's a little overwhelming for a lot of reasons. One, it's a lot of reading, which kind of sucks in them. And two, there's a lot of letters and stuff happening. So if I read this, the NR means numeric response. That's all it means, numeric response question. It says the polynomial 99x squared minus 27x can be factored to the form. That's going to be really important. So it can be factored to the form ax dx minus c. You guys have seen a lot of those in your practice booklet already. You had a couple on your first unit test. What that means, when you read something like this, that says if you factored this question, the one I'm about to highlight in green, if you factored this, it would turn into this. But you wouldn't have the letters A, B, C. A, B, C represent numbers that would be there after you factored it. That's what that's trying to say. This factored will look like that, but with numbers instead of letters for A, B, C. And then it even clarifies that, where A, B, and C are positive integers. Positive integers means they're numbers. Okay? They're all positive numbers. Place the value of A plus B plus C in the numeric response box. So your actual solution will be A plus B plus C. So you have to figure out what A and B and C all are to be able to add them together. How are we possibly going to figure out what A, B, and C are? You're going to factor. So you have to take this question, factor it, it'll look like this, and then you have to match up A, B, and C to figure out what each one of them are. I want you to just try factoring this question. Okay, so that's all you're doing right now. And then we'll talk about how to actually solve it. But they want you to take this right here, 99x squared minus 27x, and they want you to factor by removing a greatest common factor, most likely, since that's the only thing we know how to do. So try to factor that. Go ahead and try to take out the GCF. Make sure you get the biggest number that can divide into 99 and 27. If we're looking at that, and you wanted to take a GCF out of it, what a lot of people would do is they would do 3x in both those things. How many people initially were like, yeah, 3x? I saw it on a lot of pages when I was walking around. Oh, nobody wants to. That's okay. There's a lot of 3x's on pages. The biggest number that can divide into 99 and 27 is 9. Now, if you did 3x, okay, don't write this down. If you did 3x, you would have got this. And if you look at this, that's a 9. If you look at your solution, you have two numbers in the brackets that both could be divided by 3. So that's how you know you didn't get the biggest number, because you would have been left with something that could have been factored even further. So you always want to make sure you get the biggest number that divides into all of these. The biggest number that divides into all of these is 9. Just slide things up a little bit. There's going to be some space. So when you divide by 9, here's 9x to the outside. Then 99x squared would give you 11x. Negative 27 turns into negative 3. The x's cancel out. That's what it should look like factored. Now the question wasn't, what is this factor? The question was, what's A plus B plus C? And the only way you could figure out what A, B, and C were was to factor it. So you had to factor to get to the answer. See how it doesn't like deliberately tell you that? You have to kind of know that's what it wants you to do. Now, figuring out A, B, and C is where people get a lot of problems. And on our test, you have to answer it properly. You're not going to simplify yet. The problem is identifying what A, B, and C all equal. Okay? Because people look at this and they want to go A equals B equals C equals. And the problem is, it said they would all be positive integers. And what's C equal? Negative 3. A lot of people see negative 3 there and they think they've done something wrong or something else has gone wrong. So what I like to do is I take my answer and right below it, I write out the form they said I should be in. And what that's going to help me do is identify what A, B, and C all equal. A is usually easy. 9 and A, see how they match up perfectly? A equals 9. The B, people usually find pretty easy. 11 and B, they line up perfectly. B equals 11. If you look at C, notice that the negative signs line up with each other. That means the C value is actually just the 3. The C value does not include the negative. because the negative was part of the format. Does that make sense? Those are minus signs together. Then the C's are the actual numbers. So in this case, C equals positive 3. That can be really tricky. It's something that throws people for a loop. So make sure you're checking and lining up your format and making sure that the negatives actually go with each other. If they didn't, so if my format had been bx plus c, and I ended up with 11x minus 3, that's when c would equal negative 3, because the numbers, the symbols wouldn't match up with each other. And it can be tricky. There's lots of questions in your practice booklet to help you with those. So the question was the value of a plus b plus c. That means I have 9 plus 11 plus 3. Fill out my calculator. The answer is 20. That's what you would answer in your booklet. It goes in the first 2 boxes. Okay, and you also need to bubble them in your sheet. Okay, that